Hello, this is Unit 5, Video 2. You should have your Video 2 note sheet with you in order to be prepared. And you might want to actually have your notebook as well because I'm going to do some examples that I did not leave room for on the note sheet. Alright, so adding fractions together. This is going to be an algebra review that we're going to be able to take these concepts from algebra and apply them to trig. They're no different with trig, but sometimes having all the sines and cosines and tangents and all of those functions in there kind of messes it up, and we forget often that algebra, we forget our algebra skills. So here's a couple examples involving adding fractions together. Or subtracting for that matter, but 1 over y plus 3 over x. If I need to add these together, I need to have a common denominator. So I'm going to choose a different color here to demonstrate what's happening. So my common denominator is x times y. And I'm going to multiply this fraction by x over x, which is just a fancy 1. And what it does is it gives me the denominator I want, but also adjusts the numerator in a way that I didn't really affect the fraction, I just manipulated it. So I get 1x. On this one, because I need a y in the denominator, I'm going to multiply by y over y, another fancy 1, because it does simplify to 1. So then this gives me 3y. To finish adding these together, now that they have common denominators, gives me 1x plus 3y. That's it. I don't want to simplify anymore. That's my final answer. So let's try another one. This one involves complex fractions. Complex fractions are really fractions within a fraction. So I have 1 over y divided by 2 over 3. And I'm saying divided by because that's really what these fractions are. It's really 1 divided by y divided by 2 divided by 3. That's a lot of words, so we often just say over. And so this is 1 over y over 2 over 3, but divided by is really what happened. So using the notion that when you divide by a fraction, you actually multiply by the reciprocal, that's what I'm going to demonstrate here. So if I'm dividing by the reciprocal of 2/3, and then I'll be dividing by the reciprocal of 1/2, this is more or less 1 over y times 3 over 2 plus 4 over x times 2 over 1. And that's going to be a lot easier for me to simplify. So I will end up with 3 over 2y plus 8 over x. Now I still don't have a final answer because I have to combine those denominators together. So that's my next step. And my common denominator here, this is going to be what we did above in the first example, is 2xy or 2yx. Though it doesn't matter because it's all multiplication. And this one needs to be multiplied by x over x, and this one needs to be multiplied by 2y over 2y in order to get the denominator that I want. And those are, again, fancy ones. They've just been manipulated to be whatever I want them to be. So in the numerator here I have 3x, and in my numerator here I have 16y. For a final answer, it looks like I'm working backwards, but of 3x plus 16y all over 2xy. And that's my final answer using complex numbers to simplify my expression. So let's try that with some of these trigs. So this is the same thing, and the first one actually starts off using complex fractions. The secant of x over the cosecant of x. Well, if we go back to what those are actually reciprocal functions. So the secant of x is actually 1 over the cosine of x, and the cosecant of x here in the denominator is 1 over sine of x, plus, just the reverse, 1 over the sine of x divided by 1 over cosine of x. So my first step is I'm going to write these, and I'm going to change colors so you can see what's happening. So now I'm going to go ahead and I'm going to write them using the reciprocals, which explains what we're dividing by fractions. So I have 1 over the cosine of x times the sine of x over 1 plus 1 over the sine of x times the cosine of x over 1. Putting those together, I get the sine of x over the cosine of x plus the cosine of x over the sine of x. But I still need to simplify this because I don't have common denominators. So my common denominator will be sine of x times cosine of x. sine of x times the cosine of x, and those can be written in either order. Remember, it's multiplication. So this one needs to be multiplied by the cosine of x over the cosine of x, and this one will get multiplied by the sine of x over this. Oops, did I do that backwards? I did. Okay, so I want to multiply this one by the sine of x over the sine of x, and this one by the cosine of x over the cosine of x. So my numerator over here becomes sine squared of x, and my numerator on this second fraction is cosine squared of x. When I put those together, I get the sine squared of x plus cosine squared of x all over sine x cosine x. But my very last step would be to notice that my numerator has now become a Pythagorean identity, and this is now 1 over the sine of x, the cosine of x. So I know that was a lot of steps, but if you actually go step by step through this and re-watch just this last minute or two, I think you'll understand the process that we took. The only complication is that I'm writing all these letters and stuff down, and those are just my trig functions. This is my final answer. Let's try number 2, which I promise will be a lot faster. Because, again, if I use the idea that 1 over cosecant squared of x is really just sine of x, sine squared of x, and that the secant squared of x is really just cosine squared of x because of my reciprocal functions, then I could add those together and use my Pythagorean identity. The answer is 1. All right, number 3. Number 3 is one where I have to get a common denominator. And don't let the fact that it's an expression, sine of alpha minus 1 or sine of alpha plus 1, be any concern. So if I choose a common denominator, it's going to have both of those expressions in it. Think of x minus 1 and x plus 1. That'd be like what we have here. So let me grab a different color. Let's go blue again. So my denominator is going to be sine of alpha plus 1 times the sine of alpha minus 1. Same thing over here, sine of alpha minus 1 and sine of alpha plus 1. Doesn't matter which order you write it in, as long as you've got both. Which means this first one had to be multiplied on numerator and denominator by sine of alpha plus 1. And this one was the sine of alpha minus 1, and that's also in the denominator. So, but because I'm multiplying just by 1 in each of those numerators, it really looks like they almost trade places. And now I have to simplify my numerators because my denominators are the same. Sine of alpha minus 1 and sine of alpha plus 1. So when I distribute this negative sign, that's the key to this, because that is going to make a big difference in my result. I have sine of alpha plus 1 minus alpha, sine of alpha plus 1. So I end up canceling my signs, and I have 1 plus 1 is 2. Now this is not technically my final answer, but for what our purposes are today in this video, that's enough. We're going to continue number 3 in class because there's something more we can do with it. But we're going to leave it here right now. Okay, next up is multiplying expressions. So back to kind of some algebra stuff. And this should be a really quick review for us if I'm going to only give you 2 examples. If I take a quantity and I square it, the best way to do that is to write it twice to make sure that you're actually squaring it correctly. So this is x plus 3 times x plus 3, which will not give me x squared plus 9. I'm missing the middle term if I do that. So I will get x squared plus 3x plus 9, giving me x squared plus 6x plus 9. I'm also going to remind you here, and I'm actually going to use trig to demonstrate this one because distribution is something we're very familiar with. If I distribute this in, I will have 3 sine of x. Notice where the 3 goes. It doesn't go on the x. Plus, I'll get sine squared of x. Notice what's being squared. It's not the x, it's the sine. It's the trig function that gets squared. All right, let's try some of these with some real good trig. I have the sine of theta minus the cosine of theta quantity squared. So just as we did on the previous screen, I want to write this twice. And I'm going to just start multiplying it. So I get the sine squared of theta minus sine of theta cosine of theta, minus sine of theta cosine of theta plus cosine squared of theta. If I start putting these together in the center, I get sine squared of theta minus 2 sine of theta cosine of theta plus cosine squared of theta. But my last step again is to notice that I end up here with a Pythagorean identity of sine squared plus cosine squared to be 1. So my final answer here, after multiplying these, is 1 minus 2 sine of theta cosine of theta. I'm going to switch colors so we can see the difference in the next one. And again, I want to multiply out 1 plus sine of x squared. 1 plus sine of x times 1 plus sine of x, and I will add the plus cosine squared of x in a second, will give me 1 plus sine of x plus sine of x plus sine squared of x. And I'm just multiplying these out, and I'm maybe going a little fast for you, so I know that you'll understand it, but it's just a little bit fast. So take your time and really look at what I'm doing and draw the arrows if you need to. So putting that all together, I get 1 plus 2 sine of x plus sine squared of x, and now I will not forget that plus cosine squared of x, which, once again, is our Pythagorean identity, sine squared of x plus cosine squared of x equals 1. So I'm going to have the 1 I have over here plus the 1 I got from my identity to be 2 plus 2 sine of x. And that is my final answer for this one. Okay, next up is some factoring. So we're going to start simple here with a difference of two perfect squares. So hopefully you remember that when both of these quantities are perfect squares, we end up getting x minus 5 and x plus 5. Alright, well what about when we have to factor a trinomial? 2x squared plus 5x minus 3. If I need to factor that trinomial, I'll need to start by considering that I have 2x and an x, because that will make my 2x squared. Then I need to consider the last number, and the last number, being negative 3, is either going to be 1 times negative 3 or negative 1 times positive 3, because I really don't have any other options. I don't think orange is the greatest color. Let's change to red. So if that gives me some options to place numbers in here, if I place the 3 here, then this will give me 6x and a 1 here to give me 1x. Well, can I make a positive 5 out of that? Let's take a look. I absolutely think I can. If I make this positive, I get positive 6x and this one negative, which leaves me then to positive 5x in the center. So factoring 2x squared plus 5x minus 3 is 2x minus 1 times x plus 3. Can always check that by multiplying it back out. So let's see what we can do with number 6. Number 6 is the difference of two perfect squares, because sine squared of t is a perfect square and the number 1 is a perfect square. So this is going to be similar to the x squared minus 25, where I have sine of t minus 1 and sine of t plus 1. And that's it. Number 7. Number 7 is one of our trinomials. So I know I'm going to start with 2 sine of x, and then this one's going to have a sine of x, because if I multiply those together, I get 2 sine squared of x. Well, luckily there's only one option for 1. It's a 1 and a 1. And because both of my numbers are my middle number here is positive, I'm going to have to put plus signs in both of these. And that's my final answer for number 7. So let's take a look at number 8. I have a few options that can go in for a 4. I can have 4 times 1, and I can have 2 times 2. But I'm going to go with my instincts here, and that says let's just keep it 4 tangent of theta and tangent of theta. If that doesn't work, I can always go back and change it and make it 2 tan and 2 tan. So this I also have the options of 1 and 3, one of them being negative. So if I were to start and put the 3 in this position here, what would happen when I multiply this is I get a 12. Well, that's going to be too big considering I only want one tangent of theta in the middle. So I'm definitely going to erase that 3. I'm going to have to put the 1 there. So that means I have 4 tangent of theta. Then in the center here I'm going to put the 3, which would give me 3 tangent of theta. So which one do I want to be positive and which one do I want to be negative? Well, I want my positive 4 to be, I want the 4 to be positive because I want a positive left over, and then this one is negative. So this is the resulting factorization of number 8. Alright, last algebra idea to review. And this might be the toughest for us because you only learned it in Algebra 2 and it wasn't a concept that repeated from Algebra 1 and Algebra 2. And it's factoring perfect cubes. When we factor perfect cubes, we're taking a look at a quantity like a cubed plus b cubed or a cubed minus b cubed, where both the a and the b are numbers that have been cubed or variables that have been cubed. For example, if I give you x cubed plus 125, the x was cubed and the number 5 was cubed. So what do these look like? Well, it's a plus b, a squared minus ab plus b squared. Now these are formulas that you will not only use during first semester, but you will use during second semester in this class. So you will have to memorize these patterns. For the subtraction, we get a minus b times a squared plus ab plus b squared. So those are the two patterns that you will need to memorize. The only difference here is that this addition and subtraction signs change. The pattern themselves is the same. So to do this x cubed plus 125, you have to identify what your a value is and what your b value is. So in this case, x equals your a value, and the number 5 is your b value. And now it just comes to substituting these in. So you will have x plus 5, that's your a plus b. A squared would be x squared. This says multiply them together, so that's 5x. And then it says take b and square it. That's your final answer for factoring x cubed plus 125. Let's try another one. How about y cubed minus 8? This makes a equal y and b equal 2. B does not equal negative 2. The negative is built into the equation. So my factorization here is y minus 2, that's your a minus your b, times a squared, which is y this time, plus 2y plus 4, and that's my b squared. Let's try this with trig. Factor each trigonometry expression, and then we have to simplify. I'm going to try the first one with you. Given that the second has just a couple sign differences, I'm going to only try the first one with you today, and then you're going to try number 10 and bring that to class. Sine cubed of x minus cosine cubed of x. That makes a equal the sine of x, and b equal the cosine of x. So using the formula I had on my previous page, and hopefully you copied it into your notebook, I'm going to have sine of x minus the cosine of x times sine squared of x minus, plus sine of x cosine of x plus cosine squared of x. Because I see sine of x squared, or sine squared of x and cosine squared of x, I know I have my Pythagorean identity. You're going to be tired of seeing that. Sine of x minus cosine of x times 1 plus sine x cosine x. And that is your final factorization simplified. Please try number 10 and bring that to class. Alright, that's everything we're going to do on this worksheet, and we will continue to use these as we continue in class for the next couple days on verifying these.